So I would like to introduce Victoria Fleenor. She is an assistant professor of computer science and the chair of computer science, engineering, and mathematics division at Cornerstone University. And I hope I got that correct.
That's right. Thank you.
Yes, if you would just like to introduce yourself a little bit to our group.
Sure, I can do that. As Sarah said, I now serve in a role with computer science. However, previously I've had a couple of different roles. So a little bit just kind of briefly about my experience and my pathway. I actually received my first degree, I would say going back to a while ago. I got my first degree in English at the time. My school didn't even have a computer science degree. So I started out in something that I loved, which is reading and writing. And I took a programming class, actually my last semester of my first undergrad degree, which was in 1993. And I happened to go to school in the time period where many people went to school with a typewriter and came home with a computer. So in that 4 years, some tremendous things happened. The internet was a thing. It wasn't when I started, it was when I finished. There was a very elementary way to do Windows. It was like a command line interface. The way back when was a little bit more difficult than it is now. But then I went and I ended up getting another bachelor's degree with a computer-based focus. And then since then have worked through now finishing almost my second graduate degree. So those of you who think you're going to be done with school at a certain time, don't ever plan on it, because here I am still in school. And I just feel like I just will always be in school. So I did have a career as a programmer analyst for many years, and then decided to teach. And I taught for a while at Aquinas College, which is a little bit down the road from where I am now. And I've been at Cornerstone this is my 7th year.
Awesome. Thank you. I love it when you can say, I'm literally older than Google, and people are like, no, really, I am.
Yes. I don't know if it's a compliment to myself to admit that, but.
Well, I think maybe for most of us in the room, it's true. So I love it. Well, thank you for sharing that. So if you are okay, we'll kind of jump into some of our questions here. And if any of our people that have joined us have any questions, feel free to jump in and ask those. We can also share the link to the agenda for this panel in the chat, and you can add any of your notes or things in there as well, and we'll try and address those, and we can also circle back around at the end here. So we'll start off with Ron.
So when you think about the computer science experiences that you had, you mentioned when you first started up as a undergraduate and took that class. What are some of the experiences that you've had that have kind of led you to where you are today? And what are some interesting problems that you may have worked on too on the way?
Yeah, sure. So that's a good question. I often will talk to students about this because especially being a woman in this field, I know that's not the primary focus here, but a lot of the interesting experiences I've had have been just coming face to face with just the experience of often being the only woman in the room and just trying to be able to prove that I can do what, I know I can do. And so I even remember my first connection with some kind of a computer-based experience was in high school. There was one of the very first personal computers was called a Commodore Super Pet. And that's what I used in 1987 or something like that. And I had a female teacher at that time. She had been in the military and she was in her 60s, I think, still teaching K-12. And she actually taught us to write a little BASIC program. And I just think back to that and I think how unique that experience was. I'm sure there weren't a lot of other people in the 80s doing that kind of a thing. But I also realized that I was not impressed. I thought it was boring a little bit. Maybe it was a, basically green screen kind of a computer, and what we were doing wasn't really exciting. And so, just nowadays, as I try to get students passionate about computing and computing related careers, that often will come back to me, and I'm thinking of myself as a 15, 16-year-old, and I try to put myself in that place and figure out what it would have taken maybe to get me excited, because I surely did not go off to college planning to do anything with my profession related to computing. I actually went into pre-med to start out with. So, I've worked with girls who code, which is middle school and high school girls, trying to get them to learn Python and things like that. And really, I think what it takes is a little bit more than the technology. I think it takes getting people invested in something that's sort of bigger than the technology. And maybe that's a problem, or maybe that's some kind of a passion or an application of the technology. But simply just writing a program at age 15 surely did not get me excited, but it definitely was, one of my first experiences. And I'm guessing that kind of planted a seed, and later on that sort of took hold. As far as things that I've done that have been interesting, well, I've gotten to travel quite a bit in my experience in industry. I traveled, internationally, and that was really fun, getting to know different cultures and different people, spending time with those people outside of the corporate work world, whether it's going out for wings at night or something. I mean, those are just great experiences, especially in your young career in your 20s, just to get to know a bigger perspective about your world. And so for me, it wasn't about just one thing, but it was about really just working with different types of people and coming up with unique solutions that solve their business problems. And, there isn't really one thing that stands out above another, because every situation was so unique. But I think it was always more about the people and the problems and the solutions. And that's what made it enjoyable. Every day was something different, and new learning curve, new kind of challenge. And I loved all of that. Now, going forward in my education, I would say the things that now I find interesting, like at the doctorate level, are more the whys. So I know that the hows, sort of like the technology and how to use it and how to solve problems, but the things that interest me now are more, what are the problems caused by artificial intelligence, and what are the impacts of that? So some of the research I've done has to do with patents and artificial intelligence, and how does that relate to income disparity and poverty and things like that. And so really at this stage of my life, it's really more about sort of how can I help fix or at least expose some of the problems for people that are coming after me, whether it relates to data and privacy issues, or unequal experiences that people have, or lack of access to the technology and the tools. So I would say it's definitely gone from like sort of not even being interested in technology in my teenage years to actually really diving in deep and helping people solve problems. And then here more recently, just a bigger perspective of how technology affects people and what can be done to really level that playing field and give everybody the best outcomes, and try to really speak for the people that are being disadvantaged by technology.
Yeah, you bring up a really good point there too, is, even though computing and computers and technology like this has been around for a while, we're still at a beginning point, a lot of times. So many folks don't see it that way. They think it's, our kids that grow up with this, it's inherent, in their lives. But a lot of other folks out there, like anybody that's been around for more than 30 years, if you take a look at it, you're like, we're at the beginning of the hockey stick growth. We're not anywhere near where it's going to go. And those are some great points. So Sarah has the next question. Sarah.
Yeah, and you honestly kind of covered some of mine, so I'm just going to put a little spin on my question because you kind of touched on your origin story, but I would love to hear maybe a little bit more about that for you. Like, what was that pivot point for you when, like you said, coding at 15 years old wasn't that exciting. And when you mentioned that, you had this female teacher, and honestly, when Ron, Keith, and I were trying to brainstorm people that we wanted to have, I was like, we need a woman. I know a woman. and you were one of the first people that came to mind, because for me, you were that first female that I had in sort of any sort of technology role. And like, for me, that was a game changer. So I just want to let you know how inspiring you are to me.
Oh, that's really nice.
To continue on that, because for the majority, I think I only had maybe one or two classes. Like, I was the only female in any of my computer science classes. So I'm very curious for you, what was that pivot point for you that really spoke to you and said, this is what I want to do, even if I am that only female in the room?
Wow, that's a good point, because it's hard to pinpoint one thing, but I think that programming class I took my senior year, that definitely ignited something. It was too late for me to change my major. I was like going to graduate in 2 months or something. And so, I just loved it. I don't even remember who was in the room. So I don't remember if I was the only woman at that point or not. This is like 1993, but I loved it. But, I was going to graduate. So I went ahead and graduated. I got a job in my major, which was writing. I got a job as a technical writer for a software company. And I just think that was so fortuitous that I ended up working for a development organization. So I did that for a couple of years. And what I found was I was just exposed to it all the time. And so I got to kind of learn the environment, learn the code. And I think, honestly, I was one of the only women that worked there. So, I've always had this experience where I'm one of the only women. It wasn't really an obstacle for me, but I think there is something to be said about just the way that you're raised and the messages that you're told as a woman, like that you can do this. And I was raised with very parents that taught me to be very independent and were constantly supporting me in whatever I wanted to do. My teachers were doing that as well. So I never felt like I couldn't do it. That's part of it. And I have experienced that with students, and I've really had to talk them off that ledge. But some of it is just in college, I think, just figuring out what you're good at and what you like to do. And it's not just going with maybe the idea of what you think would be cool or what other people say that you would be good at, but you have to figure out really what's right for you. And some people it just takes longer. And so, I'm at this job, I'm writing, and I start going back to school to take more computing classes. And that was really the pivot point there where I wasn't even done with that second degree. And my employer said, well, would you like to have one of these developer roles? And I thought, well, I have to have this degree first. And they didn't really even care at that point. They were just like, no, we're going to put you in this role. You get it, you can figure it out. And then that was it. I just did that. I've been doing that actually ever since. So it's not just one thing. I think it's just about following what you think you're good at and continuing to move forward. And I think opportunities will open up to you. For me, it happened in a very unique way. I don't know if I hadn't worked for a software company, how that might have developed. It's hard to look back and think about how things might have happened if it went a different way. But that's just how it happened to me. It was just in an industry where it was very obvious that could be a next step.
No, and I love how you said that too, that it was, following your passions and finding what you're good at, and maybe what you're good at is not necessarily upfront. You're not thinking that I'm a good programmer, I'm a good coder, but I'm a very good critical thinker. Like maybe this might be a good path for me. So no, that's a great point that you bring up. Keith.
All right. So you've talked a little bit about, your background and a lot of the issues and different trends, I think, that you've seen along the way with computer science. But I'm wondering if we can kind of fast forward to now in your current space. So what do you find to be the most promising trends in computer science right now? And then how does that intersect with the work you do right now?
Yeah. Okay. That's a great question. So I had a little bit of an idea of what we'd be talking about beforehand. And this was one of the questions that really intrigued me. If I were to go back and do this again, knowing what I know now, I would probably get much more education in data, math, and sort of like the whole artificial intelligence direction, because I think that's the burning question now. So there will be programmers, there will be developers, there will be people doing that and doing the hardware part of it. So hardware and software, but really where it's going, I think the main push here is going to continue to be, how do we harness the power of this massive amount of data that we have? Every company has a massive amount of data right now. And their main struggle is, how do we use that for, inferring things about the future, or for competitive advantage, or for predicting what might happen next, or for just automating things that we do all the time that does take critical thinking, but can we build that into some kind of intelligent system? So I think it's, hardware continues to advance and software continues to advance, but we really need to focus on the AI, the deep learning, the machine learning. Those are the areas that are just going to, in the next 20 years, completely explode. So my college age son is actually going down that path. He's in the data science path. That's like what intrigues me the most, is the data. So I would say where that intersects with me now is my focus is sort of on what's called information maturity. So it's not just having data, having information, but how people collaborate to use that information in an efficient way and how that contributes to the success of the organization. So it's not just, data and facts and machines. It's really about the systems and processes that use that and that position that in a way that you can use to be successful. So it all works together, but that's definitely the direction I see computer science going. What are the ways that we're going to solve this problem with so much data and needing to parse that and do something with it?
Yeah, that's huge. And how cool that you have one of your own children kind of going through that so you can see kind of firsthand what that's like.
That's been fun.
And I know, that speaks to a lot of our educators too, of like how you're sort of speaking to some of the integrations of computer science, and not that it can be taught on its own. It's got to be involving math and science and social studies and culture, and how that all fits together.
Yeah, that's a really good point, because there are students who will say to me, even now, they'll say, well, I wish just like all my classes could be in computing. Like, I wish I didn't have to take history or English or whatever. And I do still think that the idea of a liberal arts education is so important, because the problems we're going to face in the future are complex. They're not just, make this happen in a certain way. They're like, you have to understand all of these other areas, economics and, history, politics, whatever. And they all, do somehow influence those decisions.
Awesome. Thank you.
I think that point about too is having that well-rounded liberal education is a really great thing, because we all need to actually and always learn from history. History has a great influence on where we go forward. Especially thinking about, I know you mentioned economics in there. To me, that's a big one, because, we all run on incentives in some way, and the incentive structures for a lot of this really drive computer science and what sort of things get pushed out there. So thinking about that, what do you think's the biggest misconception about computer science careers for the students that you work with?
Well, I think there are a couple of misconceptions. I think one is that you'll sit in a cubicle all day and code and never talk to anybody. That is definitely not true. Probably for some of us, we wish it was true. I think I saw a report about somebody that worked at Amazon at their central headquarters one time. And I think they said like more than a third of their day was in meetings, like maybe up to half of every day was meetings. So really what's very important now is just teamwork and collaboration. You can't do what you need to do alone. So the idea that if you don't like people or you don't like to work with people, you should be a techie, that is not true. You actually need, in my experience, you need to be able to work with all kinds of people. You have to be able to work with people that work on the shop floor, producing cars, but you could in an hour be in an executive's office in the main CEO branch. So you got to be able to work with a lot of people, and that teamwork and that ability to persist and not give up in those situations where you need to communicate well is very important. Maybe one of the other misconceptions is that it's all about just tech stuff. And I don't really think that's true. I think it's more about, can you solve a problem? Can you look at a problem and be creative and curious enough to solve that problem? And whether or not that entails computers or other, software, equipment, whatever, is less important than your ability to understand the problem and be able to solve the problem, and then employ whatever technology or tools would be required to do that. So algorithms, problem solving, I think is really what computer science is all about at a high level. And all this other stuff, it changes from day to day. So some of the students will ask me, what if I don't know Python, or what if I don't know this or that? And I always come back to, it's not about the language, it's about your ability to solve problems, because you can Google the other stuff, but you can't Google how to critically think about a problem. Like you guys mentioned before, you have to develop those skills over time.
Yep. So most of the programmer folks that I know, they spend, if you looked at their web browsing history, and they'll tell me this, that they spend most of their time on GitHub.
Oh yeah.
Looking at other
We
code.
Do a lot of work in GitHub.
Yeah. Trying to solve the problem, right? And trying to look at other people's solutions on that problem that you're trying to solve. So it makes a lot of sense. All right, Sarah.
Yeah, and I think you kind of touched on this a little bit in your response there. But I think what a lot of our educators are facing. Like they're intrigued with computer science and the processes, and they're starting to see some of those connections, maybe particularly within their math curriculum. But like, what would you tell those teachers? Like, why is computer science relevant to everyone, especially young students? Like, why would we share this with them? You know, why would a second grader care about computer science? You know?
Oh, second grade. So I've seen my kids come up through these classes and they've done little technical projects at different times. And I'm always interested to see what their teachers do to include that. And I think if you can connect it to something that is like important to them, I think that would make it meaningful. So simply just doing some code or some kind of technical exercise with no broader connection, I think would be difficult. But I think it is important. And here's why I think it's important. So now I can see this so clearly at my stage in my career. When you get together with a group of people that are interdisciplinary and they maybe work in different areas and you're trying to solve a problem that's maybe in the whole institution, getting over the explanation of some of these very basic concepts about why you have to do this sometimes takes the majority of that meeting. And if there was just a better understanding about just like the structure of a database or like the way that information is being input or output, or the need for that to be consistent across the institution. Like these are just some basic things that are true. I feel like those conversations could happen just more efficiently and more quickly. You know, I have these conversations frequently, whether it's you guys have this at the K-12 level and in terms of assessment and how it has to be basically done in a consistent way over time so that you can compare mathematically growth, you know, so even that is like at its heart, somewhat a technical discussion. So I think just because every industry and basically every field has computer science in it, no matter what you do, you're going to have to know basics about computer science. So I just think it would, you know, it help them communicate to people. It would help them maybe have more empathy for people that are doing this type of thing. It would also help them to collaborate with people within the organization to solve problems.
Yeah, that's great. And Cheryl put a question in there, and I don't know if you want to share that, Cheryl.
Sure.
I
was just thinking about what can the K-12 educational system do to better like prepare our students? I mean, I know not everybody's going to go into computer science, but what sort of changes would you foresee that we could try to look at? Because I work at the Michigan Department of Education, and I mean, we have ideas, but I'd love to hear what your thoughts are.
Oh, that's a big question. So I did work with the CTE board of a local K-12 high school. And this is one of the things that they explore too. Like how do you embed things within the curriculum that will maybe give a student a vision of how this might look in their future? I mean, that's the kind of thing maybe that I think about. Like some of the things I think about is maybe having students go shadow people that do this type of thing on an everyday basis, shadowing or even physically going on a trip to a place where some of this stuff is done so they can actually see the importance of it. Maybe it's a manufacturing plant where they have like robots or things like that are making the work safer and better for the employees, or talking, a requirement to find somebody who does a technical type of a career and like interview them and ask what excites them about their work. Something that's going to trigger maybe like, what's fun about this? What is exciting? Like, what makes you get up in the morning and want to go to your job every day? So these are the things that even the college students will ask them, well, what will I do for 8 hours at a job? Like they want to know, like, what does it look like when you get up in the morning and go to work? What are the things you're doing? And I think that's partially what would maybe get people thinking about a career like this earlier on. Part of our problem is students get to college and they've already put their mind, or they have their mindset on a certain career, and they don't even consider computer science, where it could be a very valuable option for them. So maybe giving them that option earlier on with some kind of an insight as to what that would look like. But But this is a question that I think just continues to be a problem, because you want to do these things, but sometimes they take a while to set up and they're difficult to configure. I mean, I go through that as a college teacher. Things that I want to do, they just take time. And so you only have so much time in a day, and you don't want to just do one thing and then not ever come back to it. I think one of the things you could do is take advantage of some of these nationwide opportunities. Like there's Hour of Code, where there's things that other people have planned for you, and you can literally just take advantage of them and not have to do anything on your own. Or if there's like some kind of competition that your students could be involved in, where they get some support from some nonprofit organization, or they get some mentoring help, you could really draw on some of these other resources and pull that in. And then that gets the students networking with other individuals as well. I mean, there's not one right answer on that, but just more exposure, more hands-on interaction, just so it maybe doesn't seem so far off and difficult. Maybe that's what it is, because it's just a little bit at a time. It's not like you're just going to know everything at once, And so sometimes I think students are just overwhelmed by the prospect of computer science in general, and they can't even imagine it. But if they could envision it, they can visualize themselves doing it. I think that's one of the keys.
Thank you. Thank you very much. That was a good answer.
No, I love that. And what you said there, it made me think around the time of Hour of Code this year, like I don't listen to her really, but Doja Cat had released a video that allowed you to code her video. And so it was cool. A big release. And so like my daughter was all about that as a 13-year-old who was like, oh, this is cool new music, but like the fact that her video was not necessarily set and released, that you kind of got to dictate the path of it, was like a cool way for her to see like, oh, this could be whatever I want it to be. It was a pretty cool experience. And for me, that was one of those things where I was like, I wish we had more of things like this that connected to people that kids can relate to in some way. And so that just kind of hooks them in a little bit.
Yeah. So if there could be things like that, plus maybe somebody just explaining how a person could use that in the classroom, because even that, like even you just saying that, like, is there any support, or is there a step-by-step instruction? Like, this is how you would do this in the classroom, and leading you through all the steps. Because sometimes even just the overhead of getting whatever this is set up is prohibitive. So yeah.
Yeah. Gives you a lot to think about, I know.
I don't know who Doja Cat even is. So
like I said, I don't listen to her.
All right, that's okay.
Time to add her to your playlist.
Oh.
All right. So I think my question flows sort of from what we just talked about. And then I see Ann Thorpe's got a question coming up next. So my question is, what advice do you have for K-12 educators that want to teach computer science? And I know you're working with students that are kind of at the college level, but thinking about our teachers that are currently in the workforce, how do we get them to begin?
So this might come from my lack of knowledge about how that would happen. Like, I have just a little bit of experience in that area. My husband works in K-12, but would someone volunteer that interest from within the teaching community, because typically in my experience, it would be like maybe a math teacher, they might have natural affinity, and then they would be asked to teach AP computer science or something like that. Is that?
Sure. Yeah. I think your computer science folks that, graduate with a degree in computer science go on often to teach computer science.
Yep.
But we have the big question right now is around K-5 or K-8.
Okay.
Like, how are you integrating this in a math class like you suggested? Or what does this look like in a ELA class, knowing that you have a background in ELA?
I think anytime you can get students in an environment where they're using a computer for something that's not a video game, but they're producing something, all of that is working toward helping their familiarity. So I even see I saw my sons work through in elementary, doing PowerPoints and being challenged to go above and beyond and integrate media with that, things like that. And obviously with COVID, they had to do a lot, through technical environments. I think probably what would be helpful within a school district would be to have an individual who would be helping develop those types of curriculum exercises, and then instructing different student or different teachers to use them at the same time. So maybe, how they have sometimes a math curriculum integrator or something, and then they will develop things and spread those across the different schools and within the different grade units. You could do something like that, because then that person would have the time to develop the approach, the outcomes, all of that. And then they could have maybe during a professional development day, some kind of a just handoff exercise, maybe lead them through that. And then those teachers would be equipped to go do it. I think possibly things like that would help get those students over this obstacle of having to come up with that content themselves. I can see how that would just be difficult. But honestly, integrating it within the other subjects is what makes it more fun. Like if you have to develop a video or something on some historical event, or, and I know instructors do this all the time, or educators do this all the time. So that's probably not new, but, getting more deep into the computer science area and doing more related to code, or even automating something like that. That's kind of a hard question. In the K-5 world. So, and often the experiences my kids have had, they'll tell me, well, we were just in the computer lab today and we were doing this and this. And I don't see that it really excites them, but I don't think it's necessarily bad either. It's just they're being constantly exposed, so they're familiar with it, and so if I wasn't excited at 15, how is a 7 or 8 year old going to be excited? They don't even necessarily know what's going on. So the more you can familiarize them, though, then I think by the time they get to the age where they can pick some kind of a major, they'll be more likely to do that. I also think another thing that we're moving toward at the college level is this idea of badges. So certificates and badges. So if students pursue learning with the goal of getting some, it's just like a little thing that says you made it through this. If those types of things were integrated in classes, then you're actually allowing the students to use resources that are already there, like Code Academy and some of those sites. And that could even be integrated as part of their grade. Like you just make it through these tutorials, you get this badge, just completing that gives you like 5% of your grade or something like that. So actually many colleges around here are actually embedding those that idea of badges and certificates within their courses, because it also gives you something to put on your resume or put out on your LinkedIn. Again, that's different age level, but for these other students, it would help them just improve their skills.
Yeah. I know, just speaking to the micro-credentialing or badging,
yes, right.
I know that's been a concept thrown around in K-12 for a little while now, and it's really cool to hear that that's being implemented at the college level. And maybe that provides a little more support for getting that rolling more in K-12 as well.
Yeah, because the other thing it does is it really gets the students into this habit of learning on their own, because they're going out to where the resources are and they're pursuing them, and they're doing that on their own time when they feel like, they have the headspace to do it or whatever. And those are the skills that we're trying to teach, because that's what you have to do in this field. I mean, the problems you're going to face tomorrow will be different than they are today. So you have to be able to learn on your own. So, I think that will be a strategy going forward for sure.
Yeah. And I just want to point out, you made a really good point about, just having teachers who leverage technology and ask students to even something as simple as, hey, go build a Google slide or a PowerPoint or something, is starting to build some of those skills that help in the future as you get into computer science. It's laying a very basic foundation, but helps make people aware. So good. Okay. I'm going to turn it over to Anne, who has a question for you in the chat.
Hi, Victoria.
Hi.
Thanks for being here. This is so interesting. I'm taking everything you've said and just kind of packaging it into this project I'm working on with our CTC over here in Ottawa County. I'm wondering if you would be able to share the work you did with them, or give us a contact name that I could contact them about how they're compacting all of this together. Where our team is working on it. The PD is actually going to take place in late August, and then throughout all of next year. And I love the idea of getting the students excited about something and something that they will carry through as they grow and move into careers as well.
So did you say CTC?
Yeah, our CTE program is called CTC. It's Career Line Tech Center, but it's the CTE program for the County of Ottawa.
Okay. So the program I was working with was CTE, and that was at Lakewood, which is over in the Lake Odessa area. And I don't know if this is the way that they all work, but they were required to have a panel of people inputting from the professional level. So we were not like a board, but we were like an advisory panel that would come in. So I wasn't involved in developing any curriculum, but just maybe giving, along with several other people, we were sort of giving the teachers some input or some support from what we found to be important at the industry level and resources that he might be able to draw from. So it was really about that teacher reaching out and getting support from the industry, even as we do in the college, we have advisory councils for our programs. So in his case, it was primarily accounting because they had some accounting classes embedded where they could then take tests and get some certificates that would basically waive the first couple of classes in college. It was sort of like a middle college type thing. But as a result of that, they were able to buy new technology, new computers and things like that in the school. And some of the stuff that we were helping with was just connections to local areas where they could go for tours and for sort of experiences like I was talking about in industry that would get them excited. So like they went to Steelcase and they went to a bank. I mean, they were able to raise money having like just internal little fundraisers, and they would use that to fund trips to some of these places as a group of upper high school students. So I don't know if that's exactly what you were asking for. That's probably not super helpful, but that's some of the stuff that they were doing.
One of the things we're really looking at is trying to add more holistic elements to the program. So thank you. No, that's helpful. Thank you very much.
I was just going to pipe in and put in a plug for the Careerline Tech Center in Ottawa County. I really think that it's so critical to have those industry voices in those programs at the Careerline Tech Center, and bringing a modern perspective and getting those employers. Like IT is something that is so common across multiple industries. Right. So it's not just, the atomic object companies, software development companies of the world. So yeah. But it's really been interesting. Ottawa Area ISD they're pulling in Anne and some other content specialists like math folks to consult with their career tech center to bring a STEM element out in all of their programs. So that's exciting as well.
Okay. So you're already doing that. That sounds great.
Yeah, my husband works at Ottawa Area ISD. He's like the assistant soup for IT and information security, technology, and safety, something like that.
Oh, cool. Okay.
Yeah, so he's really interested in graduates of that Careerline Tech Center program being potential employees of the information services department at the ISD. Okay. So interestingly enough, the organization itself is interested in the pipeline coming out of those computer science programs.
Well, the other thing that I think needs to be strengthened about those ISD tech centers is some type of more clear articulation agreements with the colleges. Because I have had a couple of students come in here. Maybe they do have stronger agreements with like some of the state colleges or the larger colleges, but they are definitely getting certification, especially network certifications, things like that at the high school level, which is really college content, but to make sure that they get appropriate college credit for that, like they would at a community college or something. I think that's something to focus on as well. So I've seen some great things coming out of those tech centers.
Yeah. And I think it's just fascinating how this conversation just really kind of naturally went to the career aspect, because that's ultimately where our students are going to be ending up, is somewhere in the real world, whether that be a career, a trade, or, doing something. And how can we prepare them to be, active, contributing citizens to our society? And in some ways, whether it's knowing how to code or it's learning how to break down a problem. I mean, if you can, put that decomposition practice into action, like that's a huge skill. That's hard to take something really big and go really, break that down into those small parts. So I think that's fantastic how we're all kind of coming at this from different angles. So I really appreciate that. I guess just wrapping up here, I'm wondering if you had any last tools or resources that you'd like to share, Victoria, that maybe you think are fun or you enjoy, or something that our participants here could say, oh, I'm going to go take a look at that after here, even if it's an article or anything. Kind of putting you on the spot, I know.
So that Girls Who Code organization was great. They have a lot of funding. And when I was working with them, with students, they had some great resources. And offhand, I cannot remember the platform that they used to teach Python, but it was like initially free. And the organization paid for participants to get like time in there. I'm going to find what that is and tell you. It wasn't Code Academy. It was something else that was teaching Python, but it was like really fun. Like it was a fun way to teach it. Like they were teaching them to have like little figures, and they were like either in a story. It was usually more like a story based and not like a game based thing. Girls just tended to gravitate toward the idea of a story kind of walking through. So I'm going to find that for you, because that was a great resource. I didn't so much have to teach the coding part, but then they had these other interdisciplinary things where you were learning about a certain subject and connecting that to the idea of some tech. Ultimately, I didn't do that anymore because that did take extra time that I did not have as I was going through my doctorate, but I'm sure there are other organizations that have something similar. And what really bothered me about that was that guys couldn't come to it. Like it was focused on girls, but then I would have boys that would say, well, is there a Boys Who Code? So like there needs to be definitely the focus on the girls getting into it, but it's really not just girls. It's just everybody. There's going to be such a need for these types of individuals going forward, like critical shortage everywhere. So we just need to get students or kids of all genders and backgrounds to be interested in this and to see this as a field for them.
When I'm in the car with my kids and I point out, they notice something or whatever, and I'm like, oh, what technical elements do you think go into that? And they're like, oh, Mom, we're not in school. But then naturally the conversation comes back around, oh, I bet you they have to turn on the lights or, things like that. So eventually they will find the activity fun. That's my goal.
Yeah. Systems thinking. They're thinking. And I always try to do the same thing with my students and my own kids. Like, look, everything you're looking at, you should think about the system that creates that and how could that system be better? So even just walking through a problem in elementary and figuring out like, what are the exact steps? Like a favorite activity that I had in my undergrad was like, teach somebody else to make a peanut butter and jelly sandwich. And like, you have to tell them every single step. And if you get one wrong, it's not going to turn out right. And it's the same way in a program. And so even getting people not just to break down a problem, but to break it down into like every single necessary step. Those are good activities to do because it gets them thinking in terms of very concrete steps that it takes to solve a problem.
That's so true. I did something very similar, only with brushing teeth because we had peanut allergies in the room. And so that was fascinating. We all had a good laugh over that. And it was even better because the school nurse participated in, and we said she was the robot who had to follow the directions. And so she had toothpaste all over her.
Oh, that's awesome. That would be fun.
Yes.
I always like to ask the question, what's a question we didn't ask you that you were hoping to talk about?
Oh, wow. Here's one. So one thing that when I go out to check on how my students have done in their internships in college, all our students have to have an internship. And one thing that I will always ask their site supervisor is, what are the attributes that students should have to be successful in a job or at your job? And literally every time what I hear is very little about technology and really more about how a person is. And so it's like the ones that I've heard consistently lately have to do with being creative and being curious and being a good team player or collaborator. And those three things, then they always say, well, and they have to like have the tech skills too. So obviously they have to have the tech skills, but You can have the tech skills and not have those other things, and you won't be successful. So you have to be able to stick with a problem. Like, that's the curious part. Like, be curious until you solve it. Like, you have to be able to keep digging and digging. You got to be creative because there are different problems every day. And you can't do it by yourself. You have to be able to like reach out and ask people for help and work well with people and not get frustrated that other people don't communicate the way that you do. So really it's really those things. And I tell that to my students all the time because they're so nervous about going into an interview and not knowing how to do this or not knowing how to do that. And I always tell them it's really at that point more about who you are, because they can teach you this other stuff to an extent, like as long as you know the basics.
Sounds like the chat agrees with you.
Yes, I see.
I'm seeing some things pop up. So thank you for taking the time to answer that. It definitely is a lot more than just the computer science skills. Got to have the creativity and the social skills to go with it, for sure. Mm-hmm. Mm-hmm. Awesome. All right, Sarah.
Yeah. So thank you so much for spending your afternoon with us. I'm so grateful that you've been able to connect and share your ideas with this group and for people to ask you questions. If they have any follow-up questions, what would be the best way they could maybe reach out to you?
Probably my email. It's victoria.fleenor@cornerstone.edu. I think you might have had it in that document.
Yep.
But feel
we'll
free
make sure
to use
that's correct in there. Okay. And we appreciate you giving of your time today, everyone. Thank you, Victoria.
Yeah, thanks for inviting me. This was very fun. It was nice to meet all of you.